Imagine an entire city floating in the middle of the ocean, capable of launching jets, commanding naval warfare, and sustaining itself for decades without resupply. This is the USS Gerald R. Ford, the new cornerstone of the US Navy's maritime power. At 337 meters long, 100,000 tons displacement, and 4,500 personnel strong, it's not just a ship, it's a mobile arsenal with the reach of an entire continent. But what truly makes it revolutionary is not just its colossal size, but its design philosophy reimagined for the unpredictable threats of the 21st century. While earlier aircraft carriers were built for 20th century wars, the Ford is specifically designed for the modern combat scenario. It is stealthy, smart, and future-ready, harnessing the power of a nuclear core and advanced electrical infrastructure to transform every system into an intelligent component. In an era of drones, cyber warfare, and hypersonic missiles, the Ford is not just part of the game, it is the arena. Its true secret lies in the fusion of steel and circuitry, making it less a vessel and more a digital fortress at sea, capable of adapting and responding to any challenge. Want to uncover more secrets of Mr. Resting Gear System? Both were world firsts on an aircraft carrier. These innovations not only improved performance, but also reduced crew workload and long-term operational costs, making the Ford a more efficient and sustainable platform. This wasn't just about upgrading, it was about shifting mindset. Ford embodies a culture. Automation, digital and adaptability now define naval vessels. Rather than follow the battle, Ford anticipates it, and that changes everything. Its ability to process large volume data in time, make autonomous decisions, and new threats, an invaluable asset in any conflict scenario. The USS Ford is the embodiment of the Navy's innovation and strategic vision, a ship that not only adapts to the future, but shapes it. The USS Ford is not just big, it's a marvel of logistics and naval architecture. Housing 17 decks, 5 acres of flight deck, twin nuclear cores, and over 3 million meters of cabling, it's a fully functioning metropolis afloat. On board, personnel enjoy fitness centers, hospitals, cafeterias, even a Starbucks, mere meters from Tomahawk missile launcher. This comprehensive infrastructure ensures that the crew can maintain a high level of morale and readiness, even during long deployments, transforming the ship into a truly self-sufficient community. This room for operational efficiency required precision engineering at every level and lateral hangar elevators. The former enables simultaneous takeoffs and touchdowns, maximizing aircraft sortie rates and minimizing downtime. The latter moves jets vertically out of service lanes, preventing deck congestion and accelerating sortie. These features, while they may seem like technical details, are crucial to the Ford's ability to sustain an unprecedented pace of air operations, ensuring that the aircraft is always ready for action. Both innovations transform the Ford's deck from a crowded runway into a seamless operation zone, ready for today's jets and tomorrow's drones. The ability to operate aircraft so fluidly and efficiently is a testament to the advanced engineering and meticulous planning that went into the USS Ford's design. It is not just an aircraft carrier, it is an adaptable aerial platform capable of integrating new technologies and responding quickly to the demands of an evolving combat scenario. The Ford's flight deck is a microcosm of its design philosophy, optimization, adaptability, and readiness for the future. Imagine directing 200 sorties a day from a platform smaller than a suburban shopping center. Supersonic jets roaring into land at 240 km/h as others launch mid-deck. That's life aboard the USS Ford, a choreography of kinetic power and millisecond timing where one slip can become catastrophe. But make no mistake, this is not chaos. It's controlled chaos, a masterpiece of coordination and technology that allows the Ford to operate with unprecedented efficiency. Behind every launch is software that integrates radar, weather, ordnance, and fuel systems. Crews operate like elite athletes, synchronized to the second, refuel, reload weapons, taxi, launch, and redeploy in a deadly loop of efficiency. Automation and artificial intelligence play a crucial role, optimizing every step of the process and minimizing human error. The ability to manage such a large volume of air operations with precision and safety is what sets the USS Ford apart from its predecessors, making it a truly revolutionary combat platform. The result? A sortie rate 25% higher than any carrier before it. That's the engineering of modern warfare. Reduce friction, increase speed, and shift the balance in seconds. The USS Ford is not just a ship, it is an integrated weapon system, where technology and human training combine to create an unstoppable force. Its ability to generate such a large volume of air power continuously and sustainably is what makes it an invaluable strategic asset for the US Navy and a symbol of its ability to project power anywhere in the world. Want to understand how technology changes the game in defense? Subscribe to receive in-depth analyses and stay up to date on the latest innovations. Beneath the flight deck lies the game changer, EMALS, electromagnetic aircraft launch system. Instead of steam, it uses electromagnets powered by the ship's nuclear reactors to launch aircraft smoothly and precisely. Imagine accelerating a 0-ton block to 240 km/h in under 3 seconds. The force is immense, but stress on the airframe is minimal. This technology represents a quantum leap from traditional steam catapults, offering greater control, efficiency, and safety. EMALS is not just about raw speed, it's computer-controlled engineering feat that transforms one of the most dangerous moments in naval aviation into a calculated and controlled routine. Twister hydraulic dampers absorb nearly 2/3 of landing energy, while the remaining energy is converted to electricity and stored on board. AAG's computer control constantly monitors tension and cable payout, ensuring safe landings, even if the aircraft touches down slightly off-center. This real-time adaptive capability is crucial for the safety and efficiency of landing operations, allowing the system to respond to unexpected variations in aircraft touchdown. Energy recovery is an added bonus, contributing to the ship's overall energy efficiency. The bridge of the USS Ford is more than a navigational tower. It's a compact command center buzzing with technology. Positioned farther aft than older carriers, the island frees up valuable deck space and improves wind flow and visibility. This strategic relocation is not just a matter of design, it is a functional optimization that enhances the safety and efficiency of air operations, allowing aircraft to operate with greater freedom and fewer restrictions. Inside, ASA, active electronically scanned array, radars, 3D sensor arrays, and AI-assisted systems coordinate everything: flight operations, missile defense, communications, and cyber monitoring. The island's streamlined design houses integrated consoles and augmented reality overlays, enabling operators to process complex threats with minimal latency. The fusion of data from multiple sensors and the intuitive presentation of this information to operators are crucial for rapid and effective decision-making in a dynamic combat environment. Artificial intelligence acts as a force multiplier, assisting in threat identification, resource allocation, and response optimization. In other words, the Ford's Island is more akin to a nerve center than a control tower. It sees, decides, and acts faster than any manned node ever could. This real-time processing and response capability is what gives the USS Ford a decisive advantage in high-intensity combat scenarios, allowing it to react to emerging threats with unprecedented speed and precision. The Smart Island is the brain behind the machine, ensuring that the Ford is not just a warship but a state-of-the-art command and control platform. At its core, the Ford runs on nuclear energy. The A1B reactor system represents a massive step forward from legacy nuclear plants. These reactors generate enough electricity for a small city and can operate for 25 years without refueling. This energy autonomy is one of the pillars of the USS Ford's ability to operate globally for extended periods, without the need for constant logistical support, making it an invaluable strategic asset for naval power projection. Beyond moving the ship's 4 propeller shafts for speeds over 30 knots, they supply clean, silent energy to every onboard system: catapults, sensors, barracks, and even coffee makers. This self-sufficiency grants the Ford unmatched endurance and operational freedom. The elimination of reliance on fossil fuels not only reduces the ship's environmental footprint, but also makes it less vulnerable to supply chain disruptions and attacks on refueling convoys, increasing its combat survivability. No embedded supply convoys, no fuel stops, no logistical chain vulnerabilities, just a floating fortress ready for anything, powered from within. Nuclear power is what allows the USS Ford to be such a formidable and self-sufficient power platform, capable of operating anywhere in the world at any time without compromising its mission capability. It is the backbone of its resilience and the key to its ability to maintain naval superiority in a constantly changing global landscape. While the Ford operates with today's jets, its engineering embraces the technology still on the horizon. Modular bays, open deck architecture, and future-ready conduits mean the carrier isn't obsolete, it's upgradable. This long-term design vision ensures that the USS Ford can evolve and adapt to new threats and technologies that will emerge in the coming decades, maintaining its relevance and effectiveness in a constantly changing combat scenario. AI-powered drones, aerial, surface, or underwater, can integrate seamlessly alongside manned aircraft. The ship features launch interfaces and control nodes built to handle new systems, such as directed energy weapons, railguns, or even cyber warfare gear. This capability to integrate future systems is what makes the USS Ford a truly future-proof platform, capable of incorporating the latest innovations as they become available, without the need for major refits or operational disruptions. This is not just a ship, it's a naval platform engineered for innovation. The Ford's lifespan isn't measured in years, it's measured in tech generations. The ability to upgrade and adapt its systems and capabilities over time is what ensures that the USS Ford remains at the forefront of naval technology, serving as a catalyst for innovation and a symbol of the US's determination to maintain its maritime superiority. The USS Ford is a testament to how intelligent design can create a platform that not only meets today's needs, but also anticipates and adapts to tomorrow's demands. Want to delve deeper into defense strategies and the future of aerial warfare? Subscribe and receive exclusive analyses of the tactics and technologies shaping the global landscape. Inside the USS Ford, power isn't just propulsion, it's lifeblood. With over 3 million meters of cable, a 13800V electrical output, and onboard systems comparable to a small city, the electrical grid powers everything from catapults to onboard cappuccinos. Gone are noisy diesel generators. The Ford runs on clean, efficient nuclear-driven electricity that delivers reliability at sea and silence when stealth matters. This transition to an all-electric infrastructure is one of the pillars of the ship's efficiency and survivability, allowing it to operate with an unprecedented level of discretion. Every subsystem, elevators, lighting, radars, HVAC, and even laundry taps into this centralized power. The elimination of steam engine complexity and hydraulic sprawl cuts maintenance and headcount, freeing sailors to focus on missions rather than mechanics. The Ford pioneers the modern electric warship model, where wires replace oil and software replaces sweat. This innovative approach not only improves operational efficiency, but also enhances crew safety by reducing exposure to complex and potentially dangerous systems. Building a 100,000-ton aircraft carrier is an engineering feat that defies imagination. Newport News Shipbuilding, the only shipyard capable of building nuclear-powered aircraft carriers in the US. It employs the superlift construction strategy, giant pre-assembled blocks transported by the massive Big Blue crane. These modules, weighing over 2,500 tons each, are precisely fitted together, reducing construction time and minimizing errors. This modular approach has revolutionized how warships are built, allowing for faster and more efficient assembly with an unprecedented level of precision. This production strategy shortens build cycles and boosts scalability. Similar to modern skyscraper construction methods, superlifts allow teams to pre-outfit entire sections, wired, plumbed, and tested off-site. Big Blue's synchronized hoists position these sections with inch-level precision, making plutonic assembly a science. The ability to pre-assemble large sections of the ship in a controlled environment and then transport and fit them with precision is one of the secrets behind the speed and efficiency of the USS Ford's construction. Launch and recovery no longer require separate windows. Thanks to the angled flight deck and lateral hangar elevators, the USS Ford can launch aircraft forward while recovering others to the side, a feat impossible on older straight-deck carriers. This synchronized choreography multiplies sortie rates and minimizes deck congestion. It's a true revolution in how air operations are conducted aboard an aircraft carrier, allowing for a continuous flow of aircraft and maximizing the ship's combat capability. Picture a bustling terminal in mid-ocean, jets taxiing out, others touched down, weapons reloaded, maintenance underway, all in perfect harmony. Radios, data systems, and deck crews operate with split-second coordination, orchestrated by the ship's integrated command network. Automation and artificial intelligence play a crucial role, optimizing every step of the process and minimizing human error. The ability to manage such a large volume of air operations with precision and safety is what sets the USS Ford apart from its predecessors, making it a truly revolutionary combat platform. The result? The Ford delivers over 200 sorties per day, up to 25% more than prior carriers. That's a shift from episodic air ops to continuous, calculated aerial pressure, ensuring U.S. forces always control the sky. The ability to generate such a large volume of air power continuously and sustainably is what makes it an invaluable strategic asset for the U.S. Navy and a symbol of its ability to project power anywhere in the world. The Ford doesn't just launch jets, it's ready to host tomorrow's armament. Its open-deck design and modular systems allow for the installation of directed energy weapons, railguns, and anti-drone packages. Integration conduits and command nodes are built into its structure from day one. This foresight transforms the Ford into a launchpad for next-generation warfare, ensuring it remains at the forefront of military technology for decades. The ability to integrate new weapon technologies is crucial for maintaining superiority in an evolving combat scenario. Directed energy might let the ship engage missiles as effortlessly as jets engage drones. Railguns could strike at hypersonic speeds with no explosive payload. Software upgrades could enhance capabilities without dry dock overhaul. This upgrade flexibility is a key differentiator, allowing the Ford to quickly adapt to new threats and technologies without the need for major refits or operational disruptions. The ability to evolve and incorporate the latest innovations is what makes the USS Ford a truly future-proof combat platform. The Ford's flight deck is a jungle of movement, chaos, and high stakes. To tame it, the Navy combines automation, AI, and augmented reality guidance. Deck crews wear smart visors and helmets that highlight aircraft, and System Check etched confidence in its steel. The ability to withstand and overcome these rigorous tests is what gives the USS Ford its reputation for reliability and robustness, ensuring it is ready for any challenge that may arise. Sea trials are the final proof that the USS Ford is a world-class combat platform, capable of operating effectively and safely in any environment. Aircraft carriers carry more than hardware, they carry history. The USS Gerald R. Ford honors America's 38th president and symbolizes national innovation. Its design draws from milestones, from steam-powered cats to angled decks, and from Manhattan Project reactors to modern AAG. It is a fusion of tradition and progress, a testament to the continuous evolution of American naval engineering and its commitment to excellence. Its architecture and systems codify lessons learned from World War II and the Cold War, while anticipating future threats. The Ford sits at the intersection of heritage and evolution, honoring tradition while charting a bold new path. The ability to learn from the past and adapt to the future is what makes the USS Ford such a relevant and effective platform in a constantly changing global landscape. It is a symbol of the resilience, innovation, and service, representing the best of American capability to project power and defensiveness of the USS Ford as a combat platform. It is a testament to the US Navy's commitment to caring for its personnel, ensuring they are well equipped and supported to fulfill their mission. With multi-mission capability, digital architecture, and future-proof design, the USS Ford sets the standard for the next generation of aircraft carriers. As rival navies follow suit, the Ford is not just influencing US strategy, it's shaping global naval doctrine. Its influence extends far beyond American borders, serving as a model for the development of future naval platforms worldwide. The ability to innovate and set the pace of technological evolution is what makes the USS Ford an undisputed leader in the global naval landscape. Its technologies, EMALS, AAG, nuclear electric power, drone integration, will become the global standard. The Ford is not just a ship, it is a catalyst for innovation, a beacon for the future of naval warfare. The ability to integrate and optimize these advanced technologies into a single platform is what gives the USS Ford its superiority and its ability to influence how navies operate worldwide. It is a testament to the cutting-edge engineering and strategic vision that have made it the most advanced and influential aircraft carrier in the world. The USS Ford is more than a warship, it is a statement of intent, a symbol of the US. This commitment to maintaining its naval superiority and leading the way in technological innovation. It represents the future of naval warfare, where technology, adaptability, and readiness for the future are the pillars of maritime supremacy. The Ford is the standard by which all future aircraft carriers will be measured, and its legacy will continue to shape global naval doctrine for many decades. Did you like our content? Subscribe to the channel, leave your like, and share this video with your friends so more people can learn about the incredible story of the USS Gerald R. Ford. Your support helps us bring more quality content to you.